Hello again, welcome back. This lesson is about the metric system, and our goal today is to learn the meanings of the everyday metric prefixes that are used, as well as to expand our list so that we know the meanings of the engineering prefixes that are commonly used in the HVAC field, like microamps and picometers and terawatts and gigawatts. Those are just a little bit beyond the prefixes that people see in normal day-to-day activities. So grab your guided student notes and let's begin. I should probably warn you that this lesson is going to look a little bit different than the ones we've had before. We're going to shift from this view to something that shows a recording that I made right before this. So we're going to try to flow from one recording to another, just to warn you a little bit. Anyway, let's get started. To begin with, did you know that every single one, every industrialized country in the world, except the United States, has officially adopted the metric system as its measurement system? Yes, all of them. That makes us feel and look, I should say, like the lone holdout, which we are, and the whole rest of the world is just shaking their head and wondering why we haven't done it yet. Now, it's not that we don't use any metrics at all. As a matter of fact, as of about 2008, about 70% of the industries in the United States have gone metric, and all of the things that the government does are metric. And that's a lot. So the question is, why? Why does everybody do this? And the nice answer is because metrics are easier. For some people, learning the metric system is something new to learn, but that's all it is something new to learn, and we learn new things all the time. This is something new to learn that makes our life better. You have learned how to use a smartphone and navigate all sorts of apps because it makes your life easier. Metrics are the same way. Just think of going metric as like you're learning to use a new smartphone. The other reason why we've done it is because if you are non-metric, you lose money. Your parts don't fit parts from people that are exporting or importing from the other countries. Sorry, that didn't come out right. When you export to another country, you need to use parts that are of a size that they can buy someplace. And if their economy is metric, you need to supply them with metric things. It's also redundant of us to have two different sizes of tools. A set of metric wrenches, a set of non-metric wrenches. Being non-metric just costs us a lot of money. And besides that, metric units are all over the place. It's not like the United States doesn't use any metrics at all. You already buy soda in 2-liter bottles. On the back of all of the labels of the food that you eat, you have nutrition information. Sodium is measured in milligrams. Metrics are there. We just have to make the plunge and do it all the time. And the metric system is superior for two different reasons. It's easier because the metric system is based on powers of 10. Multiplying and dividing by 10, 100, 1,000 is a whole lot nicer than multiplying or dividing by 12 because there are 12 inches in a foot, or multiplying and dividing by 16 because there are 16 ounces in a pound, or multiplying and dividing by 5,280 because there are 5,280 feet in a mile. That's just crazy. 10, 100, 1,000, so much nicer. And the other thing that's great about the metric system is that all of the metric prefixes have the same meaning, no matter what type of unit you're using. So if you are talking about weight, you could talk about a kilogram, and kilo means 1,000. A kilogram is 1,000 grams. If you're talking about distance, you could talk about a kilometer. That would be 1,000 meters. If you were talking about volume, you could talk about a kiloliter. That would be 1,000 liters. You could talk about a kilojoule. You could talk about a kilovolt. We have kilowatts. Kilo means 1,000 no matter what. And that's really nice because there's just a few prefixes we need to learn, and then we know everything there is to know about the metric system. Okay, so at this point, I'm going to shift over. You will keep going in your guided notes, but you'll see a different video here. So hang on and get ready for the shift.
Now that we've learned how to multiply using powers of 10, we're ready to move on to the metric system. And the key to the metric system is understanding the prefixes. Before we get to the prefixes, let's talk about the base units. The base unit for mass in the metric system is the gram. So this pen cap here weighs about 1 gram. If you wanted to find out what your weight was, you would either need a lot of pen caps or you'd need a larger unit. We use the larger unit called the kilogram. The prefix kilo means 1,000, so a kilogram is about 1,000 of those pen caps. Together they would weigh about 2.2 pounds. This carton containing 18 eggs weighs about a kilogram. And these 2 half-liter bottles of water together also weigh 1 kilogram. The meter is just a little bit longer than a yard, and the meter is the base unit of length in the metric system. So this guitar is about 1 meter long, this door is about 2 meters tall. If we wanted to measure something that was smaller, we would need a smaller unit. So a staple is about 1 centimeter wide, and the centimeter prefix, centi, means 1/100th. So it would take 100 centimeters to make a meter. The base unit of volume in the metric system is the liter. A liter is just a little bit larger than a quart. So up here on this measuring cup we have 4 cups, which equals a quart, and we just extend the line over and see that it's just a little bit shy of the liter. You might remember this from grade school cafeteria. That's a cup about 1/4 of a liter. And of course we have the half-liter bottle of water. Understanding the metric system is really easy if you know what the prefixes mean. So for example, if we had 5.2 centimeters, we would just need to know that this prefix centi means 1/100th and has a representation of 10 to the minus 2 power. So really what we're going to do is keep the 5.2, we're going to keep the base unit meters, and we're just going to translate the centi as 10 to the minus 2. We know that the minus 2 as the exponent tells us that the decimal point needs to move 2 spaces to the left. So from here we're just going to go to the left 2 spaces, which gives us a result of 0.052 meters. So here's a table showing the most common metric prefixes that are used in everyday things. You should probably pause this presentation here for a second and copy down the table so that you can study them. The most important or most commonly used ones are milli and centi and kilo. Let's look at a couple of examples. We'll start with milli. A serving of almonds contains 200 milligrams of potassium, so we can write this as 200 with a small m for milli and g for gram, milligram, or we could talk about how many grams this is. We would keep the 200, we would keep the grams, and then we would just translate this prefix milli as times 10 to the minus 3rd power. We know that means we want to take this decimal point here and shift it 3 spaces to the left. And so the result is 0.2 grams. 200 milligrams and 0.2 grams are exactly the same. Hecto means 100, or 10 to the 2nd power. If a school cafeteria used 7.2 hectoliters of milk, we could abbreviate this with 7.2 H for hecto, L for liters, or we could just talk about the number of liters. We would keep the 7.2, we would keep the liters, and then just translate the hecto portion as times 10 to the 2nd. And of course we know that the 2 as the exponent tells us that the decimal point needs to move 2 spaces to the right. And we would end up with 720 liters of milk that were used. Let's look at just one more. Kilo. Kilo is an important one. A marathon is about 42 kilometers long. This distance can be written as 42 K for kilo, M for meters, or we could just talk about the number of meters this is. We would keep the 42, we would keep the M for meters, and we would just translate kilo as times 10 to the third. We know that this 3 tells us we're going to take this decimal point and move it to the right, 3 spaces, and the equivalent result is 42,000 meters. And really that's all there is to it. Translate the prefix, move the decimal point. Here's a table showing you the prefixes for engineering notation. Some of them are probably familiar, but you might not have known exactly what they meant. Tera, giga, mega, kilo, milli, micro, nano, pico. We've done kilo and milli before, but these other ones are ones that you should add to your list and study and learn what they mean. Let's look at a few examples. Here we have mega. Mega means a million. It's represented by 10 to the 6th power. So if we had a resistance of 5 mega ohms, we would use capital M for mega, and of course the omega symbol for ohm. But if we wanted to know how many ohms this was, we would use the same process that we did before. We would keep the 5, we would keep the ohm symbol, and then we would multiply by 10 to the 6th, because that's what mega means. Of course, 10 to the 6th tells us we're going to move that decimal point to the right 6 spaces, and that would give us 5 million ohms. So 5 mega ohms and 5 million ohms are exactly the same size. Giga is 10 to the 9th. That's 1 billion. So if we had a power rating of 3 gigawatts, we would have capital G for giga, and of course W for watts. Knowing how many watts this is, we would keep the 3, we would keep the W for watts, and then we would translate the prefix giga. So we would have 3 times 10 to the 9th watts. Of course, this 9 says take that decimal point and move it 9 places to the right. And the result comes as 3 billion watts. So you see, this isn't so much different from what we did before. It just involves some prefixes that may be unfamiliar to us. One more. Let's try micro. Micro is 1/1,000,000th, or 10 to the minus 6th power. So if we had a current of 43 microamps, then we could write it as 43. This little symbol here that looks like a U with a tail out in front is called a mu, like MU, but it stands for micro. So if we wanted to know how many amps this was, we would use the same process we did before. We would have 43, we would keep the A for amps, and we would translate the prefix micro as times 10 to the negative 6th power. Since the exponent is negative, we know we're going to move the decimal point 6 spaces to the left. And we come up with 0.00043 amps. And so you can see where the prefixes come in handy. Nobody really wants to write out all of these zeros. If we have a commonly small amount, then we can talk about it with a very small unit like the microamp. But really, that's all there is to it. Just like before, translate the prefix, multiply by the power of 10, move the decimal point.
On the next page, we're ready to begin converting to other units that are not bases. All the examples we did before, we went from something with a prefix to something that didn't have a prefix. Maybe from kilometer down to ordinary meters. Now we want to go from something like the kilometer maybe down to the centimeter. It's not that much different. The thing that's important is to know the meanings of the metric prefixes. Whenever we're converting from one unit to another in the metric system, it always involves moving a decimal point because everything has to do with powers of 10. So in this table down here, you have all of the metric prefixes that we've talked about. We started with tera, giga, mega, kilo, hectodeca, got down to the base. So everything to the left of the base unit, things got larger. All of the spaces to the right of the base unit, things got smaller. This is exactly the same as the table that we had for place values, right? 10 to the 0, 10 to the first, 10 to the second. All of these things correlate. A lot of people call this the metric conversion table. Because they use it to help us convert from one type of unit to the other. Now, certainly there are other prefixes for powers of 10 that are larger than 12. We're just not going to talk about them today. All right, so here we go. We have a current of 73 nanoamps, N for nano, A for amps. And the question is, how many microamps is that? So let's see, we'll give ourselves a little bit of space here. And we'll start off by using the metric conversion table. From nano to micro, we are moving left. As a matter of fact, we are moving 3 spaces, 1, 2, 3 spaces to the left. So the space labeled micro is 3 spaces to the left of the space labeled nano. So that's all we're going to do. To convert from one to the other, we just slide. It's just a question of how far and in which direction. We're going to move that decimal 3 spaces to the left. 73 nanoamps is exactly the same as 0.073 microamps. So there we've got that little mu. It looks like a U with a tail out front. And that's really all there is to it. So if you want to use the metric conversion table to help you convert metric units, you have to remember the order in which everything comes. And you might find this mnemonic helpful. The great man, King Henry, drank beer during Christmas Mass, muttering nonsense prayers. It's just a sentence to help you remember the order of the metric prefixes. T for the, T for tera. G for giga, G for great. The great man, King Henry, drank beer during Christmas Mass. Notice that B is for the base unit, and it's the base unit that can be swapped out. Meters, liters, grams, ohms, amps, joules, whatever you want right here. So King Henry can drink a lot of things. It doesn't have to be beer. Anyway, he drank beer during Christmas Mass, muttering nonsense prayers. Maybe you'll find that helpful. Let's flip the page here. The other thing that you can do, which quite honestly is the thing that I would prefer that you do, is to learn the meanings of all the metric prefixes. There really aren't that many of them. And if you know the meanings of the metric prefixes, then you can just subtract exponents rather than counting spaces. It's important that you keep track of where you're starting and where you're going, because of course when you subtract, the order in which you subtract makes a difference. But we started off at nano, which was 10 to the minus 9, and then we moved up to the space labeled 10 to the minus 6, and negative 9 minus negative 6 is the same as negative 9 plus 6, which you know is negative 3. And the negative 3, the negative tells us that we have to move left. So the sign gives us direction, and the actual digit tells us how many spaces. Of course, the answer is not going to change at all. 73 nanoamps is the same as 0.073 microamps. Moving that decimal point 3 spaces to the left to get from nano to micro. Now, if that sounds like it's magic and just some sort of freak accident as to why that should possibly be true, you'd be wrong. Clearly, you can see that we're moving and finding a distance between 2 values. But what's really happening is that there is a division problem sitting behind the scenes. If we had 73 nanoamps, right, 73 nano means times 10 to the minus 9 power. Trying to convert that to microamps is actually asking a question. It says how many microamps are in 73 nanoamps, and that tells us we need to divide. And the power of 10 associated with micro is 10 to the minus 6. So we have to divide by 10 to the minus 6 to find out how many microamps are in 73 nanoamps. And you remember from our work with laws of exponents that this gives us 73 times, keep the base the same, and the new exponent is the exponent from the numerator minus the exponent from the denominator. So we have 73 times 10 to the minus third, which of course is exactly the same answer that we had before, but that's why we subtract the exponents. It's just the shorthand way of not having to write down all of this division and all the powers of 10. Once you get the problem down on paper, you know how it's going to work out, and you can just get to the answer faster by subtracting. All right, but that's pretty much what people do. They either use the chart or they just subtract some exponents. So let's give that a try here with one more. All right, so the first thing is that we have not the right vocabulary here. A joule does not measure current. We'll call this a power output. A power output of 3.82 terajoules. And we want to turn this into millijoules. And quite honestly, we're doing this for no good reason except to practice our metric conversion skills, because nobody would ever want to convert terajoules into millijoules. You get so many millijoules. Millijoules are really, really tiny, and terajoules are huge. At any rate, on with the question, because it's here. If you start at terajoules and you want to end up with millijoules, take a second, go back, find your chart, start at tera, end up with milli, and say how many spaces did you have to move and in what direction did you go, and then come back. So when you looked at your metric conversion chart, you saw that tera was way on the left. It was at 10 to the 12th power, and you had to go all the way down to milli, which is 10 to the minus 13 power. The space labeled milli is 15 spaces. That's a lot of spaces to count, but it is 15 spaces to the right of the space labeled tera. So we need to move the decimal point exactly that far and in that same direction. 3.82 terajoules is 3, go past the 8, go past the 2, and then we need 13 more spaces, and we'll fill those with zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 millijoules. All right, and this brings us back to that discussion that we had a long time ago about scientific notation and its advantages. Nobody likes writing all of those zeros. Expressing this as 3.82 times 10 to the 15th millijoules is a whole lot nicer. Okay, anyway, that's beside the point. If we were to do this with subtracting, personally, I think this is just a lot cleaner. Tera on the chart is 10 to the 12th. So see, the chart can still help you here. It's just we don't want to have to miscount all of those spaces. Milli is 10 to the minus 3. And we just want to subtract 10 to the 12th. Oops, sorry, hang on. We want to subtract the exponents. The exponent on the 10 where we started was 12. That's what we meant. And the exponent where we ended up was negative 3. And we just subtract the 2. 12 minus negative 3 is the same as 12 plus 3, which you all know is 15. The thing about the 15 is that the 15 is positive, which means we need to move the decimal to the right. And there you have it. That's all there is to it. So work on that mnemonic so that you can write down the table if you need it and you know which powers of 10 are associated with which metric prefixes, and then get started on your homework. Have a great night. We'll talk to you later. Take care. Bye-bye.